So I will talk to you about CodeCarbon and present you our solution and a quick demo and present you some option of CodeCarbon. So yes, I'm Benoît Courty and I'm a member of Data for Good France, and that's where I meet CodeCarbon team, and I'm now one of the main contributor of CodeCarbon. So the problem, you all know it, is global warming, and everybody needs to reduce their carbon footprint, and computing is not the worst in this world, but we are facing many attacks on IT impact, and some are legitimate and some are not. And so our solution is based on the assertion of Niels Bohr, who said that nothing exists until it is measured. So the CodeCarbon goal is to measure emissions. It's based on, it's born on the University of Mila in Quebec in 2019 with tools to estimate emission based on input on a web page. And in 2020, CodeCarbon package was launched. And in 2021, we had an API and a dashboard that I will show you. And I didn't say it, but it's an open source project, and every source code is available and free to use. And how do we estimate the consumption? We measure the power consumption of the hardware with different API for the GPU, CPU, and RAM, and we multiply it by the regional carbon intensity of electricity. So that's just the API we use, and we measure the carbon intensity. You could see it on electricity map. If you don't know it, it's a really great tool because you could see in real time from how is produced electricity in each country. For example, in Germany, you could see that solar power is increasing today, and wind, you see many things like that. So it's a great tool, and we also use annual mean of carbon intensity by default, and not real time, but you could access to real time data also. So a quick demo. Yes, the easiest. I think it's here. You could use CodeCarbon is a Python package, so you could install it with pip or conda, and you import it in your project, and you could start a tracker, do your computing stuff. For example, I could do a treatment here, the compression, and when you are finished, you could stop, and it will give you the emissions. And you could have emissions and split by GPU usage, CPU, RAM, etc. You could also use it in your project by importing the package. We have many options like decorators or things like that to import it. And to show you the result, we have many outputs. I will tell about them later, but the beautiful one is this dashboard. It's a custom dashboard made around the data we gather. So we have level of split to aggregation. You could have aggregation of the organization level. You have also a project level, then experiments level, and a run level, and the individual emission. So, for example, it's the data of the French assembly of for Lex Impact, my project. And yesterday I launched a generation of PDF, and so you could see that there are a spike in emission of our hardware. And you see metadata of on which hardware it was run in which region, and you could have a view of, if it's not really interesting here because we have only one data center, but if you have a project split in many regions of the world, you could see in which region you have the most emission. And you could also see all the regions of the world to see if it will be better to move your computing from one region to another. I will switch back to the presentation. And don't hesitate, we will have a question time after if you want to view other things. And so CodeCarbon is available in PyPy and Conda. You could use it in command line or as a Python package. Here I don't show you command line, but we have a command line, CodeCarbon monitor. So you could monitor the whole machine, even if you do Java, for example, or other languages. We support Windows, Mac and Linux. We also support offline mode if you run your process on computer that have no internet. And we have fallbacks on CPU consumption in dependence of the machine. You could have annual mean or CO2 signal in the API of electricity map. And we could output the data in CSV to custom webhook to the API of CodeCarbon to have data on the dashboard I'll show you. We have also GCP cloud logging. We are also compatible with CometML. And we are working on a Prometheus connector to augment Prometheus servers. And you have also a local dashboard and online dashboard. So there are many possibilities. I probably will do YouTube videos to make it more clear because nobody knows every options. We are 45 contributors on work time. Actually, we are more free working on the project in part-time. We are used by Hugging Face, Acrymetrics, and project like that. So don't hesitate to be our new user, I hope. And I don't look at the time. Are there sometimes available to talk about way to reduce, or is it over?
Okay, so I think
yes, it's still good. It's still good. We still have a 5 minutes.
Yeah, I think
yeah.
We still have 5 minutes. Yeah,
so some insight of way to reduce your carbon footprint. The first one, but it depends of how you work, but it could be just to move your server to another country. If you are working on cloud provider, it's quite easy. You just have to look at in which country how is produced the electricity of your data center. You also could question, if you are more project manager, you could also ask, do you really need this new functionality you have to develop? One thing to do is to measure, to compare project and solution. You could do fine-tuning of model instead of training them from scratch. And you have you could use caching, maybe for if you make an API, you could catch the result to do not recompute it each time. Do not look to make a project that is the state of the art. You could stop when you mix the requirements of the clients. You could use the GPU instead of CPU, because often the GPU is more efficient than CPU. And you could use Bayesian search, for example, instead of brute forcing parameters, trying many parameters to find the best. And there are also model pruning. That is a good way to, you could train, because training, we often focus on training, but sometimes it's inference that will really cost on the running time, and so model pruning is a good way to reduce a model without losing too many performance, and so it's really reduce inference cost. But don't go too far, because sometimes when we think, oh, I can reduce my emissions, one way to reduce your emission is just to move it to the client. For example, to move the computation of the smartphone or client. Sometimes we may have to talk about edge computing or things like that, and I don't think it's a good thing because it's way easier and efficient to change a server than to change 1,000 clients' device. So I think it's really something to think about. And that's all for me. And we have a website, a general website. We have the source code is available on GitHub. We have a documentation site, a YouTube channel I created yesterday, so there's nothing yet. And also a live chat on Gitter if you want to talk with us later. Thank you for your attention.
Thank you very much, Benoit, for the presentation. And yeah, CodeCarbon is really a great project. I think it already has quite some success with so many pull requests, and a lot of people and organizations already use it.